Imagine a world where particles can exist in infinite places at the same time and appear and disappear out of nothing. Well, it is predicted that this region of space-time exists everywhere. It comes in two parts: virtual particles and quantum foam.
Let's take all the air out of this box and zoom in. Isn't it just infinitely empty space? Nope, empty space does not exist. If we zoomed in 10 to the 120, we would find virtual particles. A virtual particle fluctuates in and out of existence for only a fraction of a second because of the Heisenberg uncertainty principle, and carries some of the properties of its corresponding real particle. It can ignore many of the foundations of physics, such as having any mass or going back in time, because it isn't actually physical. And there's still much debate about if it's real or just theoretical.
So, how did they get created? Quantum mechanics permits temporary violations. Virtual particles often come in a pair of antiparticles and particles. These pairs cancel each other out while temporarily barring energy to exist. They can spontaneously appear as long as they annihilate one another before the universe notices. So, why are they important? Virtual particles appear in physics through two main ways. The first is that they facilitate repulsion or attraction between forces. This attraction is determined by the exchange of virtual particles. For example, this electron releases infinite versions of virtual photons, and those are absorbed by the proton, creating an attractive force. This includes cases where the photon is moving in the wrong direction, but the force is still created because virtual particles are everywhere. This leads to their second role, appearing in perturbation theory. This theory uses simple mathematical tools to approximate a complicated event, such as repulsion. All possibilities of virtual particles from one particle to another are averaged to form a true conclusion. For decades, scientists believed that spacetime was a smooth, flat surface, when in reality, it's a bubbly mess. Collectively, virtual particles make up quantum foam, the shifting of spacetime on small degrees. This is what warped spacetime will look like if we zoomed in. Think of it like this soda. Bubbles appear for a fraction of a second, then disappear, like virtual particles. So how do we know they exist? The most well-known experiment is the Casimir effect. Virtual particles can also appear as long and short waves. If we take two uncharged metal plates and line them across from one another, Casimir predicted that the plates would attract. This is because if virtual particles exist, between the plates only short waves can exist, while outside both can. Therefore, the imbalance of larger waves on the outside pushes the plates towards one another. This was the exact outcome when Casimir performed the experiment, very compelling confirmation of their existence. Scientists have theorized that dark energy stems from the 6 dimensions of quantum foam. Often, quantum foam, or the accumulation of virtual particles, are overlooked as disturbances, but with further research we have found out how crucial they are and unique to physics. It is key that we continue to study these theories to understand the underlying questions of our universe. As Stephen Hawking once said, intelligence is the ability to adapt, to change.